Yeah, I'll be walking you through the Corrosion 2 CTF, which is also a vulnerable machine hosted on VulnOps platform. And I did this following the structure methodology, which we always adapt to. And it goes from the discovery to enumeration to foothold and finally the privilege escalation phase where we gain access as root. Here is a brief description of Corrosion 2, and I'll be going into the discovery. In the discovery phase, we use the Nmap tool to perform a robust scan on the target, enabling the -e, which is a service detection flag, and it allows us to know the exact services running on each of the ports. Here's a screenshot of the Nmap output. It showed us that it had the port 22 open, which is SSH port, and 80 and port 8080 open, which are both HTTP ports. The only difference is their versions. This is for the Apache Tomcat, and this is for the Apache HTTPD. Now we tried opening each port. So for the port 80, it was just the default Apache page. And then for the port 8080, which is the Apache Tomcat, it has the Apache Tomcat page. And here we can see it has the manager app and the host manager app, which are basically exposed services. And if you can get the necessary credentials, you can log into this and get admin access. Next, we began with the enumeration phase, where we used the GoBuster tool to perform directory brute force on the port 8080, which is the Apache Tomcat. And with this, we were able to discover some hidden files, such as the backup.zip, the favicon.ico, and the readme.txt. Went ahead to open the readme.txt, and it showed us this, basically an int saying there's a password and a username, the credentials needed to log in as a system administrator, hidden somewhere on the server. Now that we know this, we'll go back to our discovery here, where we found the backup.zip. To get the backup.zip on the attacker's computer, what we did was we used wget to download it. Then upon downloading it, when trying to open it, it told us it requires password. So it's a password protected zip file. So the goal now is to find a way to crack it, which I'll be explaining the process I used to crack it soon. This is proof using wget to download it onto the attacker system. Once downloaded, you can see it required password. Now that we know it requires a password, we'll use the join tool to crack it. Before we do that, we use the zip to join to get the hash of the backup.zip. Then we'll crack the hash to get the password needed. And this is the join tool, which we use to crack the hash, which was already gotten from using the zip to join. And upon cracking the hash, we're able to recover the password. Now that we know the password, we can go ahead to unzip the backup file. And this is the list of files that are being stored on there. Upon several enumeration of all the files there, the Tomcat users.xml contained credentials, which is credentials of the administrator and also the manager. And this is a very serious finding, which can be used alongside the Apache Tomcat to get a reverse shell back. So basically, we were able to find the Tomcat users.xml, which contained credentials of both the admin and the manager. And this is it here. Upon opening it, you can see it contains the username of the manager and username of admin, and also the passwords for both roles, which shows that they both share the same password. Another vulnerability. At this stage, we are done with the enumeration phase. As we found necessary credentials, we can then go ahead to the foothold phase. The whole foothold process was automated using Metasploit framework. Metasploit framework contains multiple exploits, payload, post-exploit modules, and also auxiliary modules, which can be leveraged and allows for us to automate penetration testing process from foothold to escalation. So for this, we use the exploit module, which is the Tomcat manager upload module, and we set the necessary options. Necessary options required to be set here were the remote host, which is the R host, the HTTP username, and the HTTP password, and also ensure you set the remote port to 8080 because the Apache Tomcat is being hosted on port 8080. The password, which we recovered earlier during enumeration phase, will be given to the HTTP password, and the admin username will also be given to it. The R host is basically the target IP address. Upon setting this, you go ahead and run. Once you run, you would get a Java interpreter shell. So this is proof of it. Upon running it, you got a Java interpreter shell as the Tomcat user, which is a limited user. So to explain better, the Java interpreter shell is not like the native interpreter shell. It is more limited. It doesn't allow for some post exploit to work on it, and some commands can run on it, which is going to not work well for us in the case of privilege escalation. But we would still continue with privilege escalation. So moving on to the final phase, which is the privilege escalation phase, we went ahead to automate this whole process too, using the post-exploit module called local exploit suggester. The local exploit suggester suggests proven escalation paths that can be used to gain root access. So in the first case here, we set the session to 1, which is the interpreter session. And upon running it, we're able to get these vulnerabilities. Showed us that if these exploits are being run, we'll be able to gain root access, with the most promising being the overlappers, which is being shown here. So we use the overlappers exploit and set the session to 1, which is the Java interpreter session. And upon running it, we gained a new session, but not as root. We gained a new session as a normal user, but in this case, it was the native interpreter session, which you can see here is the times 64 architecture and /Linux instead of the Java. So basically, running these exploits escalated us to the native interpreter session, but as the same Tomcat user. So to gain root access, we have to rerun the escalation host module again, which is the local exploit suggester, and use the exploit suggested. And after then, we'll be able to gain full root access. But this time around, we'll use it on the second session, which is the native interpreter session that was found, as this works better with the post-exploit module. So we went ahead to load it up once more, which is basically using the local exploit suggester, where we set the session to 2, the native interpreter session, and it gave us these exploits, with the most promising exploit being the pkexec. Pkexec is a vulnerability to the Polkit version. It basically allows for users to run command as other users, such as the way you can use sudo to run command as root user. These exploits exploited this version of the pkexec and gave us root access. This whole process was automated using the Metasploit framework. So we went ahead to use the exploit, set the session to the session 2, which is the native interpreter session, and we ran it. Upon running it, we were able to get root access. Once you're root, you're able to perform any command you want, as you are not limited. The root is the highest form of privilege available on a Linux machine. Lastly, I will be showing you a brief summary of the walkthrough, which goes from discovery to enumeration to foothold and pre-escalation, and this whole thing is done in a true life structure to make it more presentable. Before I leave, I would give some brief recommendations on what I would advise to be done to protect against such attacks. Firstly, ensure passwords are encrypted and stored properly. Another one is to add in the Apache Tomcat by disabling the Tomcat manager in production environments unless absolutely necessary, and if necessary, ensure to restrict access. Also, perform regular audits, patch critical vulnerabilities. In the case of this, the vulnerability was the Polkit, so immediately upgrade the Polkit and other core system packages to address non-privilege escalation flaws. Thank you.